Hey everyone, today we will be doing Leetcode problem of the day, which is palindromic linked list. So here we are given the head of a singly linked list and we need to check whether it is a palindrome or not. So if it is a palindrome, we need to return true, otherwise false. So let understand like what is palindrome. So palindrome is a number or string or array which we read from start or end. It reads same. So if we start from this start position and we'll go left to right, it will be like 1 2 2 1. And if we start from right to left, it will also 1 2 2 1. So this in this case it is a palindrome. But if I see for this example here, it is like from left to right is 1 and 2, and from right to left it is 2 and 1, so it is not a palindrome. Let's see the constraint here. So constraint are given like the number of nodes will be ranging from 1 to 10 to the power 5, which is like minimum there will be one node and maximum there can be 10 to the power 5 node, and the value inside that node will be 0 to 9, like ranging from 0 to 9. So let's understand like how to do this and how to tackle this problem. So we'll create some examples like how those linked lists are and how we will be doing this. So let's like write the same values like 1, 2, 2, and 1. So if it is an array, let's see. Forgot about this as a linked list. If we wanted to understand like how to do this, if it is not an linked list, what we can do, like we can check whether the first and the last are equal or not. Again, the second and the second last are equal or not. So what we can do, like we can have the two pointer approach we used to have an array, like merge array or merge to sorted array or something else. So here what we can do, we can have that low and high or start and end. We'll check on comparison, like we'll compare it one by one. We'll compare this with this. If it is equal, we'll again compare this with this. We'll do comparison until like both can overlap. So suppose we have started our low from here. We started our low from here and high from here. Will decrement the high and will increment the low if it is equal. If this is equals to this, will increment our low and decrement our high. So it will like as far as it is not overlap, like we'll do a while loop. You can say, for an example, there will be some while loop going on. It will be like while less than low less than high. So until it's not crossed and the values are coming equal, like as far as we get the values equal, we'll do like low plus plus and high minus minus, and we'll do comparison of the numbers. Once it's overlapped, we'll say yeah, it's true. And otherwise, suppose in this second example, I'll take the second one as well. So suppose we have this one here and two here, and our starting position like low will be here and high will be here. Once we compare this, we'll compare these two. In the first go, we'll get no, it's not equal, so it is not palindrome. So it's a basic approach. The array one, like here, we will create this linked list and an array. Like what we'll do, we'll iterate over this array like linked list using some pointers. We'll compare again, like we'll store this one like array. So we'll create an array like 1, 2, 2, and 1. Again, once it's completed an array, we can have two pointers. Like in linked list, we cannot have two pointers. We have only the start index, or you can say a head of a linked list, because it's a singly linked list. So as far we have this head, we can create a array, something like this 1, 2, 2, and 1. Once we have created this array, we got this array now. We can see this is array 1, 2, 2, and 1. What we can do, we can use our same approach. For I'll start from here, I'll go from here, I'll increase my left and I'll decrease my down until it's same. Once we get something different, we'll simply return false from there. Otherwise, we'll iterate completely until our low or right to left like crosses each other. So it was the basic approach. The time and space complexity for that case, like time complexity will be order of n and space will be order of n, because we have created an array and we have iterated over the list. So space and time complexity are order of n. But if I see in question here, They told like there is a follow-up question, can you do in a constant space? And most of the interviewer ask you to do in the constant space without using without creating an array. So let's do that without creating an space. So we have a concept of like what to say. There is a concept of fast and slow pointer. What slow and fast pointer do? Like there are some questions like find the mid of linked list. Okay, you can be asked like reverse the linked list or do something with the help of fast and slow pointer. So we will using the same fast and slow pointer. Suppose this is our array 1, 2, 2, and 1. We will be doing that same fast and slow pointer approach to finding the mid of the linked list. And what we'll do like we'll take this one, our slow here, fast here. What fast and slow do, like fast will go one step and slow will go two step. So like slow will be doing like slow equals to slow dot next. What fast will be doing like fast equals to fast dot next dot next. So it will go two step, slow will go one step. So as far as like the fast is not reaches to the null, here it is a null. So until it's not crossed the null, this value is not here, we can iterate this one. Like we'll send this to the next and next. This can iterate two times, this can iterate one time. So we cannot send this to the null here. What is the help of this one? Like suppose we uses this two pointer and we have something called head here, which is already pointing to this linked list. This is pointing to here, this is pointing here, this is pointing here. So what we can do, like we can break the linked list into two parts. Suppose this is our head. We use that slow and fast pointer. Slow will come here and fast will come here. Fast now cannot go here because it will go to null. What we left with, like we have completed our initial iteration as far as not null. The fast is not null. We'll iterate and we'll move our slow pointer one and fast pointer as two times. So this is our fast. It cannot go here. And now see here. Now fast has two items and the initial head. You can say it is a complete part, but if we iterate from the fast part, it what it have? It have the remaining half. So you can see one thing from here. If I see, if you want something to be palindrome, like if I say 1 2 or 1 to 1 or NAM something like this, what you need to do, like you need to, if it is it was a string, what you have done, you have taken this string, you have created one reverse of a string, like this is a reverse part. Uh, this is a string. This is reverse string, and it will also come as a null. Now, suppose something is like you can say if I say slow and fast, or you can say if this is a string, or I'll create a reverse of this string, it will come like WOLS. So is it equal? No. So same thing we'll do. We'll create a reverse of a linked list of the half part, like initial half and the second half. Well, again, compare this and this and this. See, if we reverse this part, we'll have this as a head. Initially, we don't have this address because we can iterate only single, like in a front. But if I reverse this part, now it will be the head and it has this child and this child, but we'll have only this one half part. So we'll do what? We'll get the mid step, like we'll find the mid, find mid. And second point, like break in two parts. Okay, so we'll find the mid, we'll break the two parts, and we'll reverse the second part, like reverse second part. So now, if you see here, this was our main list. Uh, 1, 2, 2, 1. What we have done, like we have break this. Will like break this one. The link, this will be break, this will be break, and this will be our new head. You can say a temporary head, I'll say for this case, or you can say this will be our, you can say it is a temporary head. I'll say this is a temp head. Okay, and it will be pointing here. It will not be have any address because we have break the link, and this is our initial head. We'll again compare head by head. This will be compared by this. This will be compared by this until one of them get finished. So what we can do? We have three steps. Like we'll find the mid, we'll break into two parts, we'll reverse the second list, and we'll compare now item by item. If it is equal, fine. If it is not equal, just break and return false. So let's code this one. Let's understand like how the code will look like. So I'll come to my code editor. I'll simply firstly I'll make a function like def reverse. Okay, re ve, and it will take a head. Okay, I'll take something like temp, or you can say head new. Okay, I'll take this one. I need what I need to do. I need to reverse this part. So we have learned like how to reverse the linked list. If not, I'll just simply give you a walkthrough like how you can reverse a linked list. Suppose you have this linked list. Same, I'll take this one. Uh, okay, so this is our linked list, and initially it have this as a pointer. What we can do, we can have a three pointer approach for here. Like previous will have some null in initial, current will be there, next will be here. What we'll do, we'll keep it keep on shifting, and what we'll do, we'll break this chain and we'll point this element to this. Like will will be like reversing the chain. You can say will reversing our index. Like you can say this will be pointing to this will be pointing to none. Again, this will be pointing to this will be pointing to this, and this chain will be broken. Here we'll left with previous, and all the null and next will be far away. So what we are doing, like we are taking the help of three pointers, previous, previous, current, and next. It will keep on shifting. You can say something like a slider window. It will come here, it will come here, and it will like you can say swap the link. So you can say it will break and create a new link within opposite order. So now our start will be here. You can say previous. We'll start from here. We'll go back. We'll go back. We'll go back, and we'll come to null. Once we get null, the linked list will get finished. So it was a basic example. Let's code it like how we can reverse a linked list first. So we'll take some help of a pointer, like we'll have a previous, we'll have some current, we'll have some head, you can say we'll have some next. Next equals to, we'll have all this as a none. We can create our current pointer as well. Current pointer, what will it have? It will have new head. We'll keep on iterating until we have the current pointer. Next we'll have the current next, and what our previous will have. Well, what we need to do, like we need to assign our previous to the current next, and initially we have a null. We'll assign the first null to the current next, and we'll do the same. Like we'll assign the previous, we'll assign the previous to the current next, and we'll assign this previous as a current, and what will be there in the current next? Like current, we cannot say current equals to current dot next because we have put this previous in the next part. So we'll do next, current next is equals to next because we have saved this part here. So this is a simple step for reversing a linked list, and we'll return here. You can say like previous. You can say head or previous something. It will do a linked list reverse. Like it will reverse the linked list. Now comes to the main logic. We'll use some two pointers like fast and slow. It will be having original head, and we'll keep on iterating until fast dot next and fast dot next dot next. So what is like, we don't need to terminate our fast. We'll keep on iterating because fast are moving two step. We need to check whether it is not a null because we will be assigning this to the fast and it will keep on checking. So what we'll do? We'll do fast equals to first dot next not next. We need to like assign two pointer next it, and slow will be like doing slow equals to slow dot next. Now it will keep on iterating until we'll end up the linked list. And same now we need to like reverse this part. We'll create some reverse. You can say uh, list. We have some reverse list. How we can have? We'll pass the what to say slow pointer to this reverse part. It will create a you can say a reverse part of a second half. First half, it will be complete, but in the second part, we'll have the half of the linked list, which is reversed from that fast to end, or you can say slow to end. Now, we need to compare this. So what we'll do, we'll compare our head, original head is there, and we have this reversed part, reversed list. We need to compare this until we found something similar or something not. So what we can do, I'll like simply check if head dot value does not equals to reversed list dot value. I'll return false from here. I'll return false. Retu false. Otherwise, what we'll do? We'll keep on like shifting our head to head dot next, and same like reversed list to reversed list dot next. It will keep on iterating and checking if it is our like values are equal or not. It is a code for checking the palindrome. Other and this is like creating a half. I'll comment this out like this is a part for um, like what we can say finding the mid finding mid. This is a code for reversing a list. Reverse the we reversing list. And now main part is there. Like we have reversed the part, we have find the mid, will create. We can say here get reverse list. And now what we do, we will compare. Here we do comparison. We do comparison of list if it is a palindrome or not. Okay. So here at last, if some everything goes fine, we'll return true from here. So let's test out our code and see if it is working or not. So it's now got accepted. We'll submit. We'll check whether our code is complete fine or not. So yeah, that's fine. Let's see you tomorrow. Bye bye.